Hello friends, so today we will discuss the modulus and argument of a complex number. Okay, so first we have to discuss the modulus. Let z is equal to x plus iy be a complex number. Okay, be a complex number. Okay, so z is equal to x plus iy be a complex number. So what is the modulus of z? The modulus of z is equal to root under x square plus y square. This is the modulus. And how we have to find the argument? So for finding the argument there are some properties. Okay, so let us draw the quadrant. Here x is positive. This is the first quadrant, this is the second quadrant, this is the third quadrant, and this is the fourth quadrant. Okay, here x positive, y positive, both are positive. Here x is negative and y is positive. Here x negative, y negative, both are negative. Here in the fourth quadrant x is positive and y is negative. So for finding the argument of a complex number we must know this quadrant. Okay, so if x is positive and y is positive, so argument of z, that is equal to theta is equal to argument of z is equal to tan inverse mod y by x when x is greater than 0 and y is greater than 0. Now if x comma y lies in the second quadrant, then theta is equal to argument of z is equal to pi minus tan inverse y by x when x is less than 0 and y is greater than 0. This is the formula of finding the argument for the second quadrant. And for the third quadrant, argument of z is equal to tan inverse mod y by x minus pi when x is less than 0 and y is less than 0. When both are negative, then the argument of z is equal to tan inverse mod y by x minus pi. And for the fourth quadrant, theta is equal to argument of z is equal to minus tan inverse modulus y by x when x is greater than 0 and y is less than 0. So these four formulas are the argument of z for first quadrant, second quadrant, third quadrant and fourth quadrant. Let us take an example to find the modulus and argument of a complex number. So our question is, find the modulus and argument of z is equal to minus 1 by 2 plus I into root 3 by 2. So here x is equal to minus 1 by 2 and y is equal to root 3 by 2. This is the real part, this is the imaginary part. So modulus of z is equal to root under x square plus y square. This implies root under minus 1 by 2 square plus root 3 by 2 whole square. This implies root under 1 by 4 plus 3 by 4. This implies root under 4 by 4 is equal to 1. The root of 1 is equal to 1. Now we have to find the argument of this complex number. So x is negative and y is positive. So it lies in the second quadrant. And for the second quadrant we have the formula theta is equal to argument of z is equal to pi minus tan inverse y by x mod of y by x is equal to pi minus tan inverse y by x means root 3 by 2 divided by minus, hence mod is there, so negative will be positive 1 by 2. So these two will be cancelled. We will get pi minus tan inverse root 3, which so tan inverse root 3 is equal to pi by 3. So pi minus pi by 3, this implies 3 pi minus pi by 3 is equal to 2 pi by 3. This is the argument of the complex number. Hope this video is helpful for you. Thank you.